In this video, we're going to discuss correlation and how it relates to comparing two quantitative variables. And it's the first place we're going to start is when you look at any correlation, you're looking at the relationship between one quantitative variable and another quantitative variable. So typically, you're going to look at a visual like one of these six, a scatter plot. And a scatter plot is always goes hand in hand with correlation, and it's really the easiest way to see um, how strong a relationship is between one variable and the other. Um, how you measure that, aside from just looking at visually, you can kind of see here as we progress from this first scatter plot over here and move left to right and then down to the right, that these dots are starting to form more of a line. Like in the first one, it's pretty nebulous. You can't see exactly which way it's going. It's starting to gain a little bit of shape here, and then as you go over here, it's probably still hard to see that it's in the form of a line. But then, really, the last three, you start to see it's starting to take on a linear shape. So the first property of these correlations is your R value. We're seeing this R equals 0, R equals negative zero point 0 or negative zero point 0.3, R equals 0.5, R equals negative zero point 0.7, R equals 0.9, and R equals negative 0.99. So the R value can take on any value, including negative 1 and positive 1, and then any number in between. Okay, so if you thought about it like almost like a spectrum or a line, you'd start with negative 1 all the way over here, and then positive 1 over here, and then if your 0 is in the middle. And any value that's any R value that's close to 0, I would say is pretty weak. So some textbooks, some authors will say anything from negative 0.3 to positive 0.3, you would say it's a weak correlation or there's no correlation. And then anywhere from, say, negative 0.3 to negative 0.7, we would say it's a moderate or moderately strong correlation. Again, that would be from negative 0.7 to negative 0.3. And then also in the positive direction as well, from from 0.3 to positive 0.7, we would say it's moderate. You can kind of follow again this like little number line here. And then last but not least, from negative 0.7 to negative 1, and then 0.7 to positive 1, we would say it's strong. And really, it's that last category um, when your variables are strong is when you want to use regression and you want to use what we're going to call line of best fit in the next video. Okay, so again, if you think about it in terms of weak, moderate, and strong, where you want to be is somewhere in this neighborhood back here or somewhere in this neighborhood over here. Okay, those are your strong relationships. And we'll give you some examples just to kind of show you what the two variables would be. Like for the first one, for example, when R equals 0, I want you to think of two quantitative variables that probably have nothing to do with each other. For example, let's say on the x-axis in your scatter plot here, you are studying the number of hours of sleep you received last night. Okay, and then on the y-axis, you're studying the distance you are away from campus. We'll say the distance away from campus. Now, there might be some relationship here. You might think the students who live farther away from campus probably get less hours of sleep at night, but if we're talking about this from a purely um, residential college where not a lot of students are commuting back and forth every single day, then you probably expect this relationship to not exist, right? The number of hours of sleep probably it doesn't depend anything on the distance we are away from campus or has no association. But think of some other variables that may be in line with the number of hours of sleep and if there's a relationship there. And maybe the number of hours of sleep correlates strongly with the number of hours that you exercise per day. Another quantitative variable, number of hours of sleep, definitely has a correlation with a student's GPA. Studies have shown that the more hours of sleep you get, the higher the GPA goes. So those are examples of more positive relationships. Let's jump down here to where R is equal to 0.09, where it's a very strong positive relationship. This would be, I always go back to the SAT example, like your math SAT score and your verbal SAT score. We'll say that's on the y-axis. Okay, and notice that this relationship is positive because as the student increases their math SAT score, their verbal score tends to go up as well, and vice versa. And one thing to keep in mind when we talk about correlation, this is a good example to bring up this point. Correlation does not imply causation, okay? Meaning that the high score on a math SAT does not influence me to get a higher score on a verbal SAT. Likewise, if I have a high verbal score on the SAT, that does not influence me to get a higher math SAT score. It's kind of like the chicken or the egg, what kind of came first. And if you can't answer that question as to what came first, then you can't say there's causation. Yet we can still say there is a strong correlation. There's a strong relationship, but we can't say that one would cause the other. Okay, so let's look at this last scatter plot and kind of see what type of variable would work. Okay, for a negative, I think sometimes these relationships are harder to think of, but think of like a downward slope line. Think of something that as one variable increases, the other one is going to go down. And in the next video, we're actually going to do an example of regression on Microsoft Excel. And in that relationship, we talk about the weight of a car and the miles per gallon for a car. When you think about it, and let's just kind of write this out here. If we had the weight of a car on our horizontal axis, okay, let's say we start all the way over here at, I think the average car weighs about 2 tons, right? So let's say this scale went from, we'll say, 0 tons over here all the way up to 8. Okay, let's just say that was our range here. As we have our smaller cars here, maybe these are hybrids, a smart car, their miles per gallon, and let's kind of put that up here, their fuel efficiency, let's say this goes from 0 to 40, okay, that car that's a smart car is going to be very, very high up on this scatter plot because they get great fuel efficiency because they're a smaller car. Whereas, if you pick out a spot right here, okay, this might be your Ford F-150. Okay, a bigger truck that weighs a little bit more, and it's not going to get the miles per gallon that, say, the smart car would get. Okay, so I'm just going to list that up here. Okay, the big picture again is as the weight of a car increases, the miles per gallon are going to go down, and it's going to go down at a pretty steady form. So I would describe this scatter plot that we just did as a strong negative. So a strong negative relationship, whereas this one over here, I would say this is a strong positive. And then we can go around real quick and just kind of do each one. This one I would say is moderate to moderate strong negative. So I'm just going to put moderate to strong. And then again, it's most likely negative. The one in the upper right, the correlation is 0.5. So I'd say it's a moderate positive. And over here, this looks pretty weak to me. Again, without even looking at the R value, don't ever overlook your instinct. And that tells me that, okay, this scatter plot, there's not really much of a relationship here. So I'd say that's a weak negative or moderate to weak negative. And then here, I would even take it a step further. And when you get exactly 0, you could say there's a weak relationship, or I would just say there is no relationship. Okay. And that's the basics of correlation. Okay. In the next video, I'm going to show you how to calculate the R value, and I'm also going to show you how to create a line of best fit and then use a regression to predict observations moving forward.